All right. Good morning or afternoon. Man, I messed it up again. Always mess it up because the only class is in the afternoon. Good afternoon, A4 Precalculus CP. I hope you're having a fantastic Friday. It's the last period on a Friday, so we're going to end it off right with some Precalculus CP. Today, what I'd like to do with you is I'd like to continue our conversation on sum and difference identities and eventually work our way into proofs involving sum and difference identities. You're going to notice that just like with the simplifying expressions when we did that, the identity proofs are really the same thing that we've been doing all along. You're now just going to be given a goal that you can work towards. So that's why I think proofs are not really a new thing, or they're not really that bad, because it's just an extension of what we've been doing before. In fact, sometimes you might even find it easier than what we've been doing before because it tells you what you should aim for. Just a couple quick reminders before we get started officially. Make sure you fill out that attendance form on Google Classroom just to mark that you're here. It's very important you do that. Make sure also that you have your microphone muted and webcam disabled, which everyone's gotten good at, so no problems there. Make sure that you check your email at the end of class today, because guess what's coming your way at the end of class today? Oh yes, it's a good old PA. Just like every week, we're keeping up with our weekly schedule of having our progress assessment being assigned to you on the last day of that we meet for a particular week. Since we do meet today on Friday as opposed to the normal Thursday, I am extending the due date by 1 day as well. So that progress assessment will be due to me by Monday night at 11:59 p.m. So as opposed to the Sunday night deadline, which is normally when those things are due, it is going to be due on Monday night instead. Okay? Does anybody have any questions or comments before we get started with what we need to do? Again, I think I covered everything. Attendance form, progress assessment, that's going to be coming to you via email again, just like before. Submitted the same way, just like before. Your grades are in Aspen, all up to date. So let me know if there's anything else. But I think we've covered everything. So let's go ahead and jump right in. What we did last class is we started talking about the sum and difference identities. If you're taking the sine of two things added together or the cosine of two things added or subtracted together, how does it actually expand and how does it work? Well, the sine of a plus or minus b is equal to the sine of a times the cosine of b plus or minus the cosine of a times the sine of b. Note that the plus or minus here and the plus or minus here means that with sine, your sine stays the same. If this is a plus b, this is going to be sine a cosine b plus cosine a sine b. If it's a minus b, you're going to see sine a cosine b minus cosine a sine b. Cosine works very similarly. The cosine of a plus or minus b is equal to the cosine of a cosine of b minus plus sine a sine b. The reason why you see this notation of minus plus versus plus or minus is because whatever the sign is here, it's going to be the opposite sign over here. So if I have a plus b, when I expand it out like this, you're going to see that this is going to become a minus sign. If I have a minus b, this will be a positive. Okay? So that's what we talked about a little bit last class. I want to do a little bit more of a recap of what we talked about last class and revisit those ideas. That'll probably take about maybe 5 to 10 minutes. And then the last bit of class, we'll go through some proofs together and see how this idea extends into proofs. So the reason why, or one of the main reasons why, there's a lot of reasons why, but one of the main reasons why these sum and difference identities are so useful is because now we could actually tackle something like the cosine of 15 degrees. 15 degrees is not one of our nice, pretty unit circle values, right? We have 30 degrees, 60 degrees, 45, 90, 0, all those lovely ones that work out really nice, but 15 is just an in-between value, right? However, with our knowledge of sum and difference identities, you could say, well, the cosine of 15 degrees, isn't that really the same as the cosine of 60 degrees minus 45 degrees? Because 60 minus 45 is 15, right? That makes a lot of sense to say that. And now because we wrote it that way, we can then use our cosine extension here, our sum and difference identity, to say, well, using this right here, cosine A, cosine B, we're going to have plus because this is a minus here, sine A, sine B. We can say this is the cosine of 60 degrees times the cosine of 45 degrees plus, again, the sign is going to switch on cosine, the sine of 60 degrees times the sine of 45 degrees. Okie doke. Now with our exact values, we can find out, ooh, the cosine of 60 degrees, that's just, what is that? Rad 3 over 2. Right? Oh no, that's 1/2. Oh, jeepers. That's 1/2. No, it's not. It's rad 3. No, it's not. It's 1/2. Oh, jeepers. Oh, that's embarrassing. That is embarrassing. Holy cow. Recorded for everybody to watch forever. Cosine of 60 degrees is 1/2. The cosine of 45 degrees is rad 2 over 2. That's all right. It's not how you fall. It's how you get back up. Here we go. The sine of 60 degrees is rad 3 over 2. The sine of 45 degrees is rad 2 over 2. We can combine those together now and say that this is the square root of 2 over 2. Oh, no. Oh, jeepers. Oh, jeepers. Over 4. Holy cow. That's 2 times 2. Plus the square root of 6. That's the square root of 3 times square root of 2 over 4. Since those have the same denominator, we can combine those together now and make this square root 2 plus square root 6 all over 4. And that is an exact value now that can represent the cosine of 15 degrees. Got to compose myself. Okay, that makes sense though, right? How that's done? It's just using our cosine sum and difference identity. Likewise, we've seen problems like this that can also go in reverse. Suppose I have something like this. We have the sine of 65 degrees times the cosine of 25 degrees plus the cosine of 65 degrees times the sine of 25 degrees. Rather than evaluate all of that out separately, which would be a big old pain in the butt, we can go ahead and look up here and recognize, ooh, this is really the same expansion that we see in the sum and difference identity, right? These match up with these. And so I could say, well, that's equivalent by the sum and difference identity to the sine, and the reason why it's sine is because, again, the pieces all line up with that sine formula up at the top of a plus b, 65 degrees plus 25 degrees. Well, what's 65 degrees plus 25 degrees? That's going to be the sine of 90 degrees, and the sine of 90 degrees is, of course, 1. Does that make sense to everybody? Hopefully we're good on that front. Okay. Lastly, we saw sometimes when we can take bigger expressions and try to simplify those larger expressions. So consider an example like this. If I'm asking you to simplify, what is the sine of pi plus x plus the sine of pi minus x, right? And we have to simplify some sort of expression like that. Well, what you could do is it's really just a matter of using your sum and difference identities twice. One for this piece and one for this piece, and then just seeing how you can combine like terms after that. So here I have the sine of pi plus x. We're going to use our sum formula up here to say that's the same as the sine of pi times the cosine of x, right? That's sine of a cosine b plus cosine a cosine of pi sine of b sine of x. So that's the first expansion. The second expansion now from the second term, we have sine of pi minus x. We're again just going to go right up here and say that's the same as the sine of pi times cosine of x minus, because again the sine is going to stay the same, the cosine of pi times the sine of x. So everybody see how that expanded out? One expansion for this and one expansion for this, these two terms over here. Now that I have all that, we can go ahead and look at how can I combine these terms and what goes on here. Look, positive cosine pi sine of x, negative cosine pi sine of x is going to cancel out. I now have sine of pi cosine of x and another sine of pi cosine of x. That's going to make 2 sine of pi cosine of x. And what is the sine of pi? Well, the sine of pi is 180 degrees. The sine of pi is 0. So this is going to become 2 times 0 times the cosine of x, which is, of course, 0. Okay. Any questions about that? Doesn't seem like it. I take your silence as no questions. which is fantastic. That means everybody's paying attention and it's making sense, which is good. Notice that if this instead of pi were, say, I don't know, pi over 6, you do the sine of pi over 6, which is 1/2. 2 times 1/2 would be 1, and so that would simplify down to the cosine of x. And this is exactly what you're going to see when we now transition to proofs, which I'm about to do for you. Instead of just having an open-ended problem that's asking you to simplify an expression like that, you would say, prove that the sine of pi plus x plus the sine of pi minus x equals 0. And really, it's no different than what you've seen here. All right, let's take a look at what that looks like right now. But again, I just want to make sure nobody has any questions on what we did last class. That's pretty much a recap of what we did. Doesn't seem like it. Doesn't seem like it. All right, so let's talk about some proofs then. Let's talk about some proofs. Okay, how about a problem like this? What if I asked you to prove that the sine of a plus b plus the sine of a minus b all divided by cosine a times cosine of b is equal to 2 times the tangent of a. Okay, you have to prove that that's true. Now that may look at first glance like a pretty intimidating thing, but it's not as scary as it seems. It's just a matter of applying our sum formula here, applying our difference formula here, and then we can just go from there like we did in the previous problem. So obviously with a proof like this, it goes without saying that the left-hand side is the one we're going to want to work with. The right-hand side, I don't even know how you would take this and try to get it to look like this. What a mess that would be. We're just going to try to take this big expression and simplify it down to 2 times the tangent of a. Watch. I'm going to start by expanding out my sine of a plus b. Remember that the sine of a plus b is the same as sine of a cosine b plus, again, the sine stays the same, cosine rather, cosine of a sine of b. Okay? Plus, now we have sine of a minus b. That's going to be sine a cosine b minus cosine of a sine b. Remember, the reason why it's a minus is because the sign of minus is going to stay exactly the same. And that whole big thing is all divided by cosine of a times cosine of b. All right? I know that looks like a lot and that looks intimidating, but not nearly as scary as it seems. Look, we have positive cosine of a sine of b, negative cosine of a sine of b. Those are going to go away. So now I have the sine of a and cosine of b. I have another sine of a cosine of b. So that's going to make in total 2 sine of a cosine of b all over cosine of a cosine of b. I want to point out before the next step, notice a common mistake a lot of students will make is they'll say, oh, cosine A and cosine B, doesn't that make cosine squared? Well, that would be true if it was cosine of A and cosine of A. If you had cosine of A, absolutely, you could rewrite that as cosine squared of A. But cosine of A and cosine of B are two completely different things. It's like if you said the cosine of X and cosine of Y, or just regular old X and Y. You couldn't combine those in any way. So just be mindful of that these would have to be the same for you to be able to condense them down. I don't want that mistake to happen. But now that I'm at this point, hopefully you're seeing, ooh, cosine of B over cosine of B goes away. I'm left now with 2 times the sine of A over the cosine of A. And now how could I rewrite sine over cosine? Well, sine divided by cosine is tangent. And that leads us right to our goal of the right-hand side. And so our proof is complete. Again, the sine over cosine is our quotient identity that you can see right on this little sidebar here. Any questions about that at all? Let's jump into another one then. If you do have a question, though, please, please, please do not be afraid to interrupt. Another proof. Let's see if we can prove that the sine of x plus y times the secant of x times the secant of y is equal to the tangent of x plus the tangent of y. Okay? We're going to try to see if we can prove that the sine of x plus y times the secant of x, oh, sorry, not the sine of y, my fault. Secant of x times secant of y. Sorry, I wrote that incorrectly. I actually made the same exact mistake in my A3 class. That's the secant of x, secant of y. Let me just repeat it one more time so it's clear. We have the sine of x plus y times the secant of x, secant of y, equals the tangent of x plus the tangent of y. We're going to try to prove that that's true. Okay? What I would do first is I would look at sine of x plus y. We're going to work with the left-hand side. And I can expand that out using my sine sum and difference identity. I can say, well, the sine of x plus y is the same as the sine of x times the cosine of y, right? That's sine of a cosine of b plus, sine is going to stay the same, cosine of x, sine of y. And that is all being multiplied by the secant of x times the secant of y. Everybody sees that, right? Now I can go ahead and distribute. We can take the secant of x, secant of y, and multiply it to that. Secant of x, secant of y, and multiply it to that. Take a look at what we're going to get. It's going to come out to be, we have the first term, sine x cosine y times secant x, secant y. And the second term is going to look like cosine x, sine y, secant x, secant y. Okay? Maybe you're already kind of seeing where this goes, because even though we have a lot of terms all kind of grouped together, if we rewrite everything in terms of sine and cosine, we can say, well, this is equivalent to the sine of x times the cosine of y. By our reciprocal identity, we can say that the secant of x is 1 over the cosine of x. The secant of y is 1 over the cosine of y. Ooh, cosine of y, 1 over cosine of y are going to go away. I'm going to be left with the sine of x over the cosine of x. And we'll get back to that little bit in just a moment. Over here in our second term, we have cosine of x times the sine of y times 1 over cosine of x, again by the reciprocal identity, and 1 over the cosine of y. That's the secant of x, secant of y. Cosine of x, 1 over cosine of x is going to go away. We now have plus the sine of y over the cosine of y. And then the same expression here both times. How do we rewrite that? That's just a quotient identity. Sine over cosine, just like in the previous problem, is the tangent of x plus the tangent of y, which is the right-hand side goal that we were aiming for. And so our proof is therefore complete. Any question about how I was able to do that? All feeling good about that? All right. I have just one more problem to end the day today, and then I just want to remind you of a couple things at the end of class, but we should be done a couple minutes early today, which I guess makes up for the fact that we've stayed a couple minutes later a couple times, and I appreciate that, by the way, but we'll let you go a couple minutes early on this Friday afternoon. So let's go ahead and just do our last problem, and so we can be on our way. But if you do have any questions, do not be afraid to ask. Let's try to prove, last problem, that the cosine of pi minus theta plus the sine of pi over 2 plus theta is equal to 0. Okay? Just to refresh our memory, I'm going to write them down here, the little cosine and sine sum and difference. The cosine of a plus or minus b is cosine a, cosine b, minus plus, the sine switch, sine a, sine b. And the sine formula as well, we're going to need the sine of a plus or minus b is sine of a cosine b plus or minus cosine a sine b. I highly recommend having those formulas handy throughout while you're doing any sort of assessment or work based on this stuff. I also, if you haven't done so already, I'm sure a lot of you have done so already, but make sure that you have your unit circle information, your exact values handy, because that's certainly going to come into play here. I'm sure you've already realized that when we've done some problems at the beginning and you were probably like, ooh, I need to get my unit circle stuff out. I know you guys are awesome, so I appreciate that. All right, let's go ahead and tackle this problem now. If I dropped my pen. We have the cosine of pi minus theta. So we can use our cosine sum and difference identity down at the bottom here, and I can say, well, that's the same as the cosine of pi times the cosine of theta plus, because remember the sine and cosine is going to, the sine and cosine, sorry, that's confusing. The fact that we have a positive here would switch to a negative here, and the fact that we have a negative here would switch to a positive here. So the fact that I see a minus here means it's going to become a plus. Sine of pi, sine of theta. Plus, second expansion, we have sine. That's going to be the sine of pi over 2, cosine of theta. The sine and sine stays the same. Cosine of pi over 2, sine of theta. Right? That's just, again, breaking down our first formula here. I can draw it in a little bit here. And breaking down our second formula here. All right. Question about that breakdown. Again, I want to just emphasize one more time the fact that, remember, cosine switches signs. It goes to its cosine, and sine, the sine and sine is the same sign. Sine has the same sign. All right. Now I can go from here, and I can see how can I combine these terms together, if at all. Well, let's see if we can actually do a little bit of work. It doesn't look like we have any like terms per se, but let's see if we can do a little bit of work with figuring out these exact values. What's the cosine of pi? The cosine of pi, let's see, pi is 180 degrees, so the cosine of pi would be -1. So I have -1 times the cosine of theta. That's how I could rewrite that. Plus, what's the sine of pi? Well, pi is 180 degrees. The sine of pi is 0. You don't move vertically at all to get to 180 degrees. Plus, the sine of pi over 2. Pi over 2 is straight up and down. That's 90 degrees. So the sine of 90 degrees, that's 1. Cosine of theta, maybe you already see where this is going. Plus, cosine of pi over 2, again, that's 90 degrees. That's 0 times the sine of theta. Look at what we have going on here. 0 sine of theta and 0 sine of theta are going to cancel out. I am now left with -1 times the cosine of theta plus +1 times the cosine of theta, which of course is going to equal 0, the same as the right-hand side. And just like that, our proof has been completed. Any question on that at all, in any capacity? Okay, just a quick recap of what we did today. What we did today is we wrapped up our conversation on sum and difference identities. I started by reminding you of the sum and difference identities at the top. The sine of A plus or minus B is sine of A cosine of B plus or minus cosine A sine B. The cosine of A plus or minus B is cosine A cosine B minus plus, so we switch the sign, sine A sine B. It was useful, this is useful for a variety of reasons, but one of the main reasons is the fact that we can now find the sine and cosine values of these in-between angles, where we can just string them together here and realize that, oh, 15 degrees is the same as 60 degrees minus 45, and we get an expression like that. We've also seen problems where we can go in reverse, and we could take an expansion, reduce it down, and then simplify like that. And lastly, we can simplify expressions like this by just applying the identities wherever we need to, and we saw that this particular example came out to be 0. That then extends to proofs, where proofs, really the same as simplifying, just with an end goal, allow us to now just interject all of these sum and difference formulas into there, and they really work the same way as the problems we've been doing before, where I just apply my identities, I try and simplify my terms as much as possible, and I work towards this goal. We saw that in this problem. We saw that in this problem with a little bit of distributing, and we saw that in this final problem with, again, a little bit of expansion and combining like terms. Keep in mind, again, your unit circle exact values are super handy to have. Please make sure you have access to them. If you need another document of the unit circle exact values, it's on Google Classroom, so please make sure you have that. All right, just a couple reminders before we wrap up today. Again, we do have a progress assessment at the end of the week. It's the end of the week. Of course, we have a PA. It is going to be due on Monday night. You should be receiving the email at exactly 1:30. I have it scheduled to go out then. So that should arrive in your inboxes very soon. Just like before, make sure you take a picture of your work and reply to the email. Everybody seems to be very comfortable with that. There haven't seem to, the first time we did it, there was a couple tech issues, but it seems like those are all worked out now. So if you do have any tech issues, just feel free to let me know, but it seems like we should be on track to meet that Monday night deadline. Again, the deadline is Monday night as opposed to Sunday night because we have class on Friday instead of Thursday, so it's just shifting by a day. The last thing I want to remind you is just to remember that these videos are recorded and posted online. They are all linked on Google Classroom. There's a playlist of them. So if you ever need to watch them back to see some more examples or just maybe hear me reiterate something again, please do so. That's why they're there. They're there to benefit you. So don't let that opportunity pass you by. But other than that, we've reached the end of our pre-calculus journey for the day. I hope you do have a fantastic weekend. Happy Mother's Day to all the mothers out there. I hope you enjoy your weekend. I will see you guys again on Tuesday. So enjoy your weekend. Have a great day. Thank you for everything today, and I will see you next time. Bye, everyone.
Have a nice weekend, Mr. Giorgio.
Have a nice weekend. See you, Sophia.